Welcome all. In this lecture, we are going to see about the list data structure in Python programming. Yes, we will go into the list data structure, right? This is the first data structure we are going to learn in Python programming, and this is the most important data structure used widely in all Python programming, right? In any scenarios, sometimes I can say that this is one of the uh, data structure which I cannot omit in any of my programs, right? So we will see what this primary data structure is, right? List is one of the most versatile data type. Why? Because it can store all data items of any data type separated by commas. If I need to declare a list, what I need to do? I need to have all the data items separated by comma enclosed inside square brackets. So what a square bracket is this. I will have brackets this. This is actually called as square bracket, and all list or data structure are represented using square bracket. I can store data items of any data type, say it to be a string data type or number data type, or in numbers I have integer, floating point, everything, and any data item I can store in list separated by comma. Here I have an example for you, which is list 1 equal to physics, comma, chemistry, comma, 1997, comma, 2000, right? Enclosing inside square bracket. So this is actually a list having 4 items with strings and numbers. So I have 2 data items, the 2 types of data items present. All are separated by commas and enclosed inside square bracket. I have another list 2, which is actually completely a number data item, or more clearly it is an integer list. And here I have a string list, or I can say it is a string of one length, so it is a character or list, and this is also enclosed inside square bracket. So I will say this is also a list, right? Now you understood how to declare and initialize a list. Just have a sequence of data item separated by comma enclosed inside square bracket, right? Now we will see how to access a list. We know how to store elements inside list. Now we need to see how to access. So we had a mechanism for storage. In future, we need to access element inside the list, right? How to access it, how to manipulate those elements, everything we need to see. Let's see those. In accessing, we need to understand a thing called as indexing. So what is indexing? So for each element in a list, I will have something called as index, which represents its position. In Python, all indexing of any data structure starts from 0. So the index always starts from 0, not only for list data structure, for any data structure you have in Python, indexing starts from 0. So what will be the index? For example, if I go with this particular list 1 is equal to Python physics, comma, chemistry, comma, 1997, comma, 2000. So physics will go with index position 0, chemistry is index 1, 1997 is index 2, 2000 is index 3. So this is actually the index. If I need to access the first element, that is the first index, chemistry, what I will do, I will just use the list name. What is my list name? List 1 of 1. Here I have specified list 1 of 0. So it is actually going to access my 0th element, which is physics. So it is also all the indexing will be done with the name of the data structure with the index position enclosed inside square bracket. The main thing you need to understand here is this square bracket used for indexing is different, and this square bracket used inside list data structure is different. Here among the data structures, we have different brackets to denote the difference, right? So list is having the notation as square bracket. But all the data structure indexing will go with square bracket, which is actually different. So these two square brackets are different, which you need to understand. They are actually items separated by commas. Here it is actually indexing, right? So list one of 0 is physics. If I say list one of 3, it is 2000 and so on, right? I was just using the index of each data item and then accessing the particular data item. If I say list 2 of 1 colon 5, right? What is this colon? This colon can be uh, represented as slice operator, or together I can say it as a range operator. I can say it as a range of data item. So I can specify it as a range of data item or a slice. I'm just cutting the list and then taking a slice out from it. Here my slice will have a start index and then end index. So my start index is 1 and end index is 5. So I will give an index to it. This is 0th index, first, second, third, fourth, fifth, and sixth. So I have an index for my list 2. My list name is list 2. And it is saying that I need to take a slice between the range 1 and 5. So what will happen? My 2 will get printed, 3, 4, 5, but the final last end index will not be taken into consideration. Only from 1 to 5 it will be taken, and I'll get the result as 2, 3, 4, 5. If I say the index is going to be 2 colon 6, what will happen? I was going to take 3, 4, 5, 6. 7 will not be taken. Why? Because the last index will not be taken into consideration. So that is what I mean, right? So last index will not be taken into consideration when you go for the range operation. Negative indexing. One of the most famous features of Python is negative indexing. You can access a list from front to rear. Also, you can come back and access the same list from rear to front. This indexing is common for all the data structures in Python, not only for list. So how it comes? When I go from front to rear, it is 0, 1, 2. And when I come from rear end, it is actually -1, -2, -3. So this is actually the case. So it is actually called as negative indexing. And how I do with this negative access, I just say the name of the list. My name of the list is this list of -1. So this list of -1 corresponds to cherry. I can also access the same as this list of 2. So in positive access, it means this list of 2. In negative access, it means this list of -1. Similarly, this list of -2 is banana. Right? So I have both positive indexing and negative indexing possible in Python for accessing the element in a data structure. Range. So we have just seen how we are using the range, and elaboration on why it is included and not included. See, the search will start at index 2, which is included, and end at index 5, which is not included. The final element is actually not included. Say for example, I have apple as index 0, banana as 1, cherry is 2, and orange is 3, kiwi is 4, melon is 5, and mango is 6. Right. This is a 7 element list. So 0 to n minus 1 is 0 to 6. When I go for this range, my start index is 2. So I'll start from cherry, orange, kiwi, but I will not take melon because the end index should not be included. Right. So my answer is cherry, orange, and kiwi. Right. I got this as result. By leaving out the start value, the range will start at the first item. Yes, what will happen if I didn't specify the start index? If you didn't specify the start index, the start index will be by default 0. You actually will start from 0, but the compiler will automatically substitute 0 for the start index if you didn't specify the start index. So you said the slice should be :4. So you didn't specify the start index, so we will take it as 0:4. So it will take apple, banana, cherry, orange, but the fourth thing, kiwi, will not be considered because it is the last index. So it will be up to orange, right? So this is with respect to the slicing when I didn't specify the start index in the range. Similarly, what will happen if I didn't specify the end index? Here I start from 2. So my second index is cherry. So 2, 3, 4, 5, 6. And I don't specify the last index. If last index is not specified, I will go till end of the list and print everything. Or I can say if last index is not specified, my last index will be substituted as length of the list. My last index will be substituted as length of the list. So this is length of this list. I have a function which you will see in the subsequent slides. The function length of list will give me the length of the list. Right? This function is used to give length of the list, right? So if you didn't specify the last index in the range, then compiler will automatically substitute the last index as length of this list. So it will be substituted as 7. So I'll get up to 6, all the elements. So I'll get cherry, orange, kiwi, melon, mango. I'll get everything. I'll get everything printed on cherry. So now you understood how to access an element, how to use the range method to use the list grouping. If I didn't specify the start index, the indexing will start from 0. And if I didn't specify the last index, the slicing operation will take until the length of the list. Now, negative indexing. What will happen if I do it in the negative indexing way? Just name it in the negative index from the rear end. Mango is -1, melon is -2, kiwi -3. Just have a negative indexing, you'll get to it very easy. Now -4 is orange. Now what will happen? You start from -4 and go till -1. So I take orange, I take kiwi, I take melon, but I will not take mango. Why? Because here mango is a last index which should not be considered. So I got the result orange, kiwi, melon. So negative indexing is also very simple. Just to take from the start index and go till the end index previous value. Don't take the end index. Changing items. How can I update an element in a list? Yes, updations are possible. It is very easy. If you want to update, for example, apple is index 0, banana in index 1, cherry in index 2, and I need to replace banana with blackcurrant. What I will do, I will just say this list of where banana is actually being positioned. It is positioned in the index 1. So I say this list of 1 is equal to blackcurrant. Now banana will be replaced by blackcurrant and I will get apple, blackcurrant, cherry. Similarly, if I need to replace cherry, I say this list of 2 is equal to orange or some other fruits which I like, I will put and replace cherry. Right? So replacing is very simple in a list. Similarly, now going into the looping. How can I access every element in a list? How can I do it? I can go for a for loop. What for loop does? If I have a list, say for example, apple, banana, cherry. I say for x in this list, print x. What x will do? X is actually an object variable. which will take all the data items of this list one by one and do the operation. The operation here is just printing the particular data item. So it will take apple, print it. Next iteration, it will get banana. In the next iteration, it will take cherry. One by one, it will get access to all the elements in the given list. That is with respect to for loop. If you need to access all the elements in a loop, then you can use for X in this list. If I need to use a conditional statement, what I need to do? Just this is a very simple. Why? Because a simple English is enough to crack this. That is, if I need to check whether apple is present in my list or not. I have a list which is apple, comma, banana, comma, cherry. I need to check whether a data item apple is present in the list. So what I say, if apple in this list, what will happen? Apple will be checked here. Yes, apple is found. Then I'll say yes, apple is in the fruits list. I just print it out, right? Very simple. If apple in this list. So this in is also an operator which performs this matching operation, right? Some other keywords which are actually present in list are len, which is used to find length of the list, that is number of elements present in the list. Append is actually an updation method in list which is used to update other list objects inside my list. Insert is used to insert an element in a particular index in a already existing list. Remove of, if I in remove is a method, if I give a data item in remove function, that particular data item will be removed from my list. Similarly, I have pop. Pop is a function which is by default removes the last element in a list. It also removes element with respect to index. If I say pop of 3, that is the third index element will be popped out, that is removed. Right? If I need to delete the entire list, I will just say del, the entire list item will be deleted. Entire list data structure itself will be deleted. That is the final operation. Hereafter, that list will not exist. If I say clear off, all the elements alone in the list will be cleared off, but the list will exist. Only the elements will go off, but the list will be existing. These are actually some of the methods which are available in list data structure. Copying, right? So when you do copying, for example, if I have A is equal to 5, and if I need to give this A to B, I can just say B is equal to A. So now B also will have the value 5. So in this case, you cannot say that if I change the value of A in future, B also will change. I cannot say that. But when you go for data structure list, if you assign like this, list 2 is equal to list 1. In future, if I change the list 1 elements, list 2 will automatically get changed. That is the feature of this direct list assignment. If you assign a list already having elements to another list, it means that you are actually copying it with respect to its reference. So if list 1 changes, list 2 also has the same change happening automatically. So if you need to avoid this so that the older value of the list get preserved, you need to use a method called as copy. This copy of method will actually preserve the older values and will not copy by reference. It just copies the values. So this list is equal to apple, comma, banana, comma, cherry. And if I need to have a copy of this my list with respect to values alone, I just say my list is equal to this list dot copy of. Now my list will have apple, comma, banana, comma, cherry. In future, if you change this list of 1 is equal to blackcurrant, banana will change to blackcurrant, but the change is reflected only in this list. But my list will have my list of 1 as banana only. This will not be updated. But this is not the case in this list 2 equal to list 1. In this case, if you change it to blackcurrant, list 2 also will change to blackcurrant, right? So if you need to proceed with the reference copy, you need to go with list 2 equal to list 1. If you need to have the values alone to get copied and stored, you can use dot copy of method, right? There is also another way to do this. We will see what it is. That method is list. Just you create another list with respect to this list. That this list is my own list having the elements apple, comma, banana, comma, cherry. I can also use my list is equal to list of this list, right? So what actually I'm doing is I can actually create a list, or I can actually convert any data structure to other data structure by just saying the data structure name. For example, if I have a data structure tuple, which you will study next to this, if I need to convert a tuple to a list, I just say list of the tuple. Next, what will happen? The tuple will now convert into list. I can also convert a list to a list. That's what is happening here. Maybe a kind of stupidity, but I'm actually making a copy using this. So what actually I'm doing? I'm doing my list is equal to list of this list. So this is actually being copied and stored in another object called as my list, which is not having any reference to this list. So this will serve as a copy, right? So in this way also I can have a copy of this list. So there are two ways of copying. One is dot copy of method, and here it is list function. Joining to list. This is actually very good, right? Joining to list is if I have a list 1. List 1 is equal to a comma b comma c. List 2 is equal to 1 comma 2 comma 3, right? So this thing is very simple. If I have an addition operation between a 2 and 5, 2 plus 5, I'll get an addition result as 7. So 2 plus 5 will get me 7. But if I say 2 like this, which is actually a list of one element plus another list 5, what will actually happen is I cannot get the addition result. This time the plus operator will behave as a joining or concatenation operator. So it will give me 2 comma 5. Now it is actually a joining term which will join all the elements in a given list. So it will give me 2 comma 5. Similarly, if I have a list 1 is equal to a comma b comma c. List 2 is equal to 1 comma 2 comma 3. If I use plus operation to join them, I'll get list 3 as a comma b comma c comma 1 comma 2 comma 3. So I get a new list, and that will be a joining of both. But list 1 is actually still a comma b comma c, and list 2 is actually still 1 comma 2 comma 3 only. List 3 is a new list which is created by joining list 1 and list 2, right? There are also other methods which will make a list more usable, right? The first method is append method, which is used to append a new data structure inside the list object and make that object itself updated, right? Next is actually clear method. This method will clear all the elements or remove all the elements from my list. Copy, you already know, copy method is used to create a copy of a list and store it in another list. Count method will count the number of times a particular element occurred in a list. Example, if I have a list of 1 comma 2 comma 2, if I say count of 2, how many times 2 occurred is 2 times. I will get that count. Extend is also a updation function or updation method in list, which is used to extend my current list, right? It is not going to uh, insert an object insert a new object inside my list. It is going to extend or increase the number of elements in my list, which is already existing. Next is index, which is for if I say index of a particular element, I will get the corresponding position of the element. If I have 1 comma 2 comma 3, if I say index of 3, I'll get 2. Index of the element 3 in that list is 2. That's what I will get. Or if I have more than one time the same element is occurring, I will get the first occurrence, or I will get the index of the first occurrence of that element. Insert, insert is used to insert a new element inside a list at the given index. So you can specify the index as well as the element, and the element got insert in that position. Next we have pop. As we already saw, it will by default remove the last element from the list, or I can also specify the index which need to be deleted. I can also specify the index of the element which I need to remove by using the pop method. Remove method, here instead of specifying the index, you need to specify the element which is need to be removed, so that element will get removed. Reverse of, as the name specifies, is used to reverse the order of the list, and the sort of is used to sort the list in ascending order, right? In the next video, we will see all these methods practically in a hands-on session, and we will understand list data structure in even more detailed fashion. In this lecture, as a summary, we have seen how to initialize a list, how to use the list, how to access the element in a list, how to use the indexing, either it be a positive indexing or negative indexing, how to use the range in slice operation, and we saw important keywords and methods in list, and we know how to use for loop and if conditional statement in list, right? In the next video, we are going to see about the methods of list practical. Thank you.